Hey everyone, Michael Unger here with another edition of Ask an Astronomer, and it's Asteroid Day. So, of course, we're bringing in our trusted astronomer, Marley. Hey, Marley, how's it going?
It's good. I'm glad the sun is back, but enjoyed our brief break the other day, which was very nice.
So, the big question is, what does an astronomer do to celebrate Asteroid Day? It's a big day, I assume, for people in your community.
My personal opinion. It is a big day, especially, it is kind of one of those around the world things that really gained a lot of traction in the past decade or so. But I don't know, the best way to celebrate Asteroid Day is to just talk about asteroids and what Asteroid Day actually is, instead of just our normal programming, which is all about the news.
So, how are you personally going to celebrate?
I'm going to probably watch Armageddon later. Not the most realistic movie ever made, but it does the job of a movie, which is entertain me for an hour or so. So
Right.
probably going to watch that later.
Okay. Well, we've got the theme for today's show. Of course, if you're here and you have a space question about anything, drop it into the chat. If you're here on YouTube, if you're watching on Telus Optic, come on into YouTube and you can ask Marley and I some questions live. We do this every 2 weeks at 2 p.m. on Thursday. Today's theme is Asteroid Day. Asteroid Day is something that is actually celebrated. Celebrated is kind of a weird word. It's a day of of
Yeah.
knowledge, right?
Yeah.
It's something scary, but then there is also some exciting things because we're figuring out ways to save humanity, and that's something to be celebrated, right?
Oh, definitely. It is one of those days where, yeah, celebrated is a weird word to use in terms of you don't celebrate it, but it's more of like discussing the possibility of asteroid collisions with Earth and also what can we do about it and how can we better our technology to look for those risks before they become like large risks.
Right. So we're going to focus in on asteroids. So if you've got questions about asteroids, throw those into the chat. Plus, I've got a special bonus for anyone watching. If you want to play along, I've got a Kahoot game, 5 big questions. As you can see here, I have a really cool rubber asteroid that I can send to someone. Someone can pick it up. These are really fun to throw at people. If you're feeling annoyed at them, no, throw these at other people. But I use them quite often when I'm always need something to fidget with when I'm at my desk. So they're really nice because you can squeeze them and release some tension in your workday. So we'll do that at the end, but let's get going. Let's learn about Asteroid Day. How did this all come about and start?
So how did Asteroid Day start? Well, I didn't make a huge slide about how Asteroid Day began, but how it started is it's a global day of awareness, I guess is a better word to do it instead of celebration. Yeah. Awareness would be the word. And its purpose is to educate the public about asteroids and kind of emphasize the importance of defending our planet against possible impacts. And it's observed every year on June 30th. And it was co-founded by many different people in the astronomy community, one of them being Dr. Brian May of Queen, who I need him to, again, one more year of asking him to drop his hair care routine. Really would love the details on that, Brian.
But he's got really big hair, right? Like that's
really big and really curly. And I'm like, how do you get the ringlets to stay? Please tell me. Anyways, it was co-founded by him and many other people. And at the time of launch, when the Asteroid Day was kind of launched as a day to observe, it was in 2014. And there was an estimated 1 million near-Earth asteroids, what are called near-Earth asteroids, which we will get into a bit later, that were over 70 meters in diameter. And that's another important measure that we'll talk about. And it was thought that only about 1% of them had been discovered. So of the 1 million that we estimated were there, we had only discovered 1% of them. And so involved in Asteroid Day was this 100 times declaration, which was a call calling for to increase the rate of near-Earth asteroid discovery 100 by factor of 100 within the next 10 years, or discovering 100,000 near-Earth asteroids a year. And as of now, there are, I think, 207 different signatories on this 100 times declaration. So people who emphasize this and agree with calling for this increase in developing technology to help us find asteroids, including Chris Hadfield, Canadian astronaut Chris Hadfield, is one of the signatories on this 100 times declaration. So it's very much we live in, on a planet that came off of a bunch of, different bits coming together, and those bits are still running around from the early solar system. And so being aware of where those are and what their orbits look like helps protect not only us, but also, worlds and impacts from any human stuff we do.
And I think what's interesting about this day too is that this isn't a NASA day. This isn't even a European Space Agency day. This is actually an independent organization, like you say, that had these signatories that came in to realize that this is a global issue, and this isn't just one country or one space agency that should really be focusing in this. It affects all of us. This is not at the scale of global warming. Of course, that is a very big problem for our planet, but this is on that list, and it is also something that is going to affect everyone too. So it is something that is good that even though we don't have an imminent asteroid coming towards us tomorrow, but at some point in humanity's future, it may happen, right? So we need to be prepared for that.
No, and also knowing that it's happened before. The reason June 30th was picked was to mark the Siberia Tunguska event, which was this event, many years ago, which was this large, basically, asteroid flew into the atmosphere, came down as a meteor, and it produced a fireball, which is a very big explosion in the air as it broke apart before it hit the ground. And it flattened several hundred, kilometers of trees and stuff, and was this very large event that caused a lot of damage in a rural part of Siberia. And it was lucky that it was rural because, there was not a lot of damage done to people, but we have seen asteroids do similar things, or meteors, as they enter the atmosphere. And, in Russia, I think a couple of years ago, when it flew through a city in Russia and broke up in a fireball, you had window shattering, and no one was injured by the asteroid or the meteor itself, but they were injured from the glass and stuff as everything was broken. So it is something that we see, and we know that there have been mass extinction events from asteroids, like the dinosaurs being taken out by an asteroid impact. And so it is something to be aware of, and something that there's a large call for turning our technology towards being better at finding these objects.
Oh, those poor dinosaurs. They didn't even know it was coming. I mean, it's not their fault. So you talked about NEAs, near Earth asteroids. So what really constitutes a near Earth asteroid?
So it's kind of arbitrary, really, what we decide is near or not. And so basically what we've decided, a characteristic for a near Earth asteroid, is that its perihelion, or its closest approach to the sun, has to be within 1.3 astronomical units. So 1 astronomical unit is the distance that is from Earth to the sun, the average distance between the Earth and the sun. And so 1.3 AU is just, just a little bit over our orbit from the sun. And so with this, perimeter, we have decided that constitutes being near. There are nearly 30,000 asteroids that make up near Earth asteroids that we have found, and they break themselves down into 3 main groups. And the groups are decided based on orbital properties of these asteroids. So we have the Amor asteroid groups, which they tend to lie between Earth and Mars, and they never cross Earth's orbit. So even though they're within that 1.3 AU, their perihelion, they never actually cross our orbit at all. Then we have the A10 asteroids, and their furthest point is greater than Earth's closest point. So their aphelion is greater than Earth's perihelion. And so they will occasionally cross Earth's orbit. And same with the Apollo group of asteroids. Their perihelion is smaller than Earth's aphelion. So they do have a crossover, and those will also occasionally cross our orbit. So of these near Earth asteroids, there are 3 groups. 2 of these, well, there's 4, but 3 big ones. The 4th one is debated. But of these 3 groups, 2 of them will occasionally cross into our orbit, and the other ones just don't. They're just kind of there.
Okay, very cool. And by the way, you are mentioning these terms, perihelion and aphelion, which we celebrate Earth's perihelion usually in January. But you may know, Marley, that next week, actually on Monday, we will be at aphelion, which is when we are furthest away. Even though here in the Northern Hemisphere, the weather is heating up, but we will actually be furthest away from the sun, which I think is pretty cool.
It is very cool, but we are just tilted towards the sun right now. So that's why it's still summertime.
So getting back to asteroids, and this dinosaur killer, we often see these very clickbaity articles that come out that get everyone sort of like really riled up. So what's really the risk of that that we're under right now?
Yeah, so this is a headline that my brother sent me just the other day, basically a very clickbaity headline that we get, like a giant comet is coming, will it hit us? The answer is like usually like almost 99, no, it will not. Like it's not going to hit us. Otherwise, like we'd have more than just a headline coming out if this were to happen. So what we actually need to worry about are not the near Earth asteroids. They're just near, but it's better to worry about what we call these potentially hazardous asteroids. And so this is like a categorization within a category. And so these PHAs, as they're called, they tend to be at least, to count as a PHA, you have to be at least 140 meters in size or 140 meters in diameter. And you have to pass within 0.05 astronomical units. So a very, very small amount of our orbit. But when we think of it, it's 0.05 AU, that's still 7.5 million kilometers. So it's still a very large range. And so this graph I downloaded today from the Center for Near Earth Objects run by JPL out of on behalf of NASA is all of the near Earth asteroids discovered. And so all of them that we have, there's about 29,000 that we know of. And of that 29,000, the potentially hazardous asteroids are about 2,270 of them, right? So a much smaller amount. And of those ones, only 152 are greater than 1 kilometer. It's the 1 kilometer ones have a larger risk just because they're bigger. But the worry starts at 140 meters. So you kind of just want to break it down into the categories of things to worry about. And the other half of this is, okay, so now we have a category that counts as things that could be hazardous, but how hazardous are they? Like, how do we determine the risk of something like this? And we actually have a couple ways, but they kind of always boil down to the orbit, how the asteroid's orbit works, where it may cross paths with Earth, its size, and then some other stuff thrown in there that have to do with what it's made out of and a bunch of other things. And that will give you the risk. But the problem with calculating risk is that our orbits and our sizes are both based on imperfect data. So asteroids may have a very long period. They may have a very long year going around the sun. And so we may only see them once every few years or, something like that. Think about Halley's Comet, which we don't see very often at all. And so we can only get orbital data when we're able to see it. And the more data we have, we end up getting better and better models for what could be happening to this asteroid. And so because it's based on imperfect data, the risk becomes harder to calculate.
Interesting. So, and of course, that number will increase the more that we find, right? And that's really kind of like the big unknown is that once you get past sort of like the Jupiter range, it's very hard to find these asteroids, right?
It's very hard to find it. You also have to think about any asteroid that comes at us from behind the sun is going to be very hard because the sun will block out a lot of the light. Or all of the light. So it's very hard to, number one, find them. And number two, if you only have one orbit, you've only been able to detect it once on its closest approach and gather all the data you need, you're going to have a lot of margins of error because it's only the one time you've seen it. Whereas if you've seen the same asteroid 500 times, you can get much, much better data and put it together, lower your uncertainty for its orbital dynamics and stuff. But yeah. It's a very difficult science to get accurate because we don't see them very often, right? So it's hard.
And I guess that really gets back to the nature of this work, which is very collaborative. Because if one's set of astronomers in, say, one part of the world, calculate an orbit, that's just one. That's going to be needed to be confirmed by multiple astronomers around the world because the calculation orbits, it's hard to do that kind of work, and you're going to need more data to look at this, right?
Yeah, especially if an asteroid is only visible for 2 or 3 nights, you're not going to have a lot of time to collect a lot of data and that it's gone for 5 years or so. Yeah. It's a very imperfect science, but nevertheless, we try to get it done and we've been successful with getting it done. And we end up getting these 2 different scales to kind of communicate risk for it, because what good is having the risk of an asteroid if we're not able to actually tell people what that risk is. And so the Torino scale on the right-hand side is the one that's used to convey risk to the public. So we have global, regional, local, no consequences on the right-hand side of the graph with the kinetic energy in megatons, so how much energy would be released with this asteroid's impact on the left, and on the bottom, the collision probability. So what is the likelihood that this thing is actually going to hit us? And so the scale goes from 0 to 10, because asteroids and meteors do get close to us kind of all the time. Like shooting stars and stuff still count as impacts, right? But they burn up in the atmosphere. So that's where the size and the material of the asteroid comes in, and the meteor comes in. So the Torino scale is for the public. The more one that is more scientific that is used is called the Palermo scale. And this is what NASA and the European Space Agency use to categorize risk. And it's used by specialists, kind of like the same way the Richter scale is used for earthquakes. The Palermo scale is also logarithmic based. So, moving from, if it rates a 1, moving up to a 2, it's 10 times more dangerous or whatever, more of a risk. So this is what the scientists use. And relative risk, really what it gets down to, is given by this giant equation in the second one on the red, which is the impact probability of the event, which relies on the data we're able to get from the orbit of the asteroid. DT is the time until the event in years, which also comes from the orbit. And F lowercase b is the annual background impact frequency. So this is a very important part of this whole conversation. It is that we are in space and there are asteroids. And so there's always a background risk that we're going to be impacted by something that needs to be considered. And that E is the energy in megatons of TNT. So this annual risk is, not huge, but it's still there. And so sometimes an asteroid that may come close doesn't really have a larger risk than the background than what's going on. And so it's not something really to be worried about at all.
Yeah, that's very interesting, because this gets me thinking about even things like public health and how scientists, look at this from a slightly different place, because there is many potential risks, but they're going to have to narrow that down in order to understand which ones are the ones we should really be worried about, because there's, sending a mission to an asteroid is quite costly, and we're already starting to do it, but we have to choose, right? And we have to choose wisely,
Yes.
as somebody once said in the Indiana Jones movie. That's the important part of this work.
It is. It's choosing wisely, and also, realizing that there's you have to weight things, so we may have a probability that an asteroid has a 10 to the -4 probability of impacting Earth in the year like 2185. And it's like, okay, well, between now and 2185, we could get a lot more data that may change that. So that may have a lower risk associated with it, right? Like the Torino scale won't even be assigned to asteroids that have impact dates 100 years, more than 100 years in the future, because that far along, the data just stops being reliable, kind of like it just doesn't mean anything once you get more than 100 years in the future, because the amount of times we've seen the asteroid is not comparable to the time that will elapse from that estimated impact.
Okay, good. So we've got our categories. We've got the ones that are at risk. So where are we at now? Where are we at currently? What are we keeping track of? What should we be worried about, and what is sort of in that higher risk scale?
Well, the thing is there's not things that have a super high risk. Actually, there's actually not much to be completely worried about. But what we've been doing so far is like just kind of keeping track. So we do have at least the Center of Near Earth Studies by JPL and NASA has these two databases called Sentry and Scout. So Scout is a short-term database. So let's say they detect a near-Earth object, whether that be an asteroid or a comet, that's unconfirmed. They're not sure if it's a near-Earth one, if it's just passing through. What Scout does is it monitors and analyzes possible trajectories, so possible orbits for that object. And once it becomes confirmed, it gets moved over to Sentry, which is a long-term database. And what Sentry does is analyze the full range of possible orbits for near-Earth objects into 100 years into the future. So basically running several equations, several algorithms to see how that orbit will change, move around in the next 100 years. And from that, it's able to calculate the probability of impact. And over time, the more data we get of this object, the more times we observe it, the object actually usually ends up being removed from the list of risk asteroids. So it usually ends up being taken off. We may start with having an asteroid that has a very high probability of colliding with Earth at some point. The more we see it, that probability goes down until it's no longer a risk and it's removed entirely from the list. So this is kind of what we've been doing so far.
Okay. And so which is there any in particular that we know about that are sort of like at the top of this sort of like middle range of things we're keeping an eye on?
The biggest one, the asteroid that actually currently has the highest impact risk, according to that CNEO database, is actually asteroid Bennu, the one that Psyche went to. Not Psyche, sorry, OSIRIS-REx went to, that took a sample, is now on its way back, actually has the highest Palermo scale risk, but that risk is still negative 1.5. And this scale goes into the negatives, into the positives. The higher the number, the higher the risk. And so the highest risk we have for an asteroid is still negative 1.5. So very, very low risk in terms of what could happen. And it's interesting looking at this one is that it started off very high, and then not very high, like at negative 1.5, and then it dropped very sharply down in the 2014 to just below negative 2.3. So the risk went down. But then with the arrival of OSIRIS-REx and studying the asteroid and how it was moving, that risk went back up, back to about the negative 1.6, 1.5 side with asteroid Bennu. So it's still always in flux, but still a relatively low risk.
Okay, this is great. We've got a few questions coming in, Marley. So why don't we we'll wrap up with some of the questions, and we'll end off with a little trivia. So Harry, asks about the mining potential. So OSIRIS-REx went to Bennu. The samples coming back next year, right?
Yes.
So besides mining, is there any other practical uses? Any industries worth interest?
Industry, I can't really speak on. I guess mining is like the biggest one. I look at asteroid exploration from the side of like scientific understanding. So asteroids are very interesting, and comets as well, is that they're kind of like time capsules from the early solar system. And so learning about how asteroids work and what they're made of and how old they are and stuff can offer insight into the early formation of our solar system. So how Earth may have looked and things like that in the earlier times of our own solar system. So industry-wise, I'm not too sure, but there could be other ones, but I don't know. Mining is the big one I know.
Okay, we got another question from Bast Active. How long has it been accepted that anything actually lands on Earth? So, I mean, how far back do we go? Do we start realizing that things were landing on Earth? I think is what that question means.
Oh, like asteroids hitting Earth? Like how long ago was that accepted? Oh, I mean, it's kind of my whole life, it's kind of been accepted that things hit Earth. I'm not sure to give an exact date, but I know it was found that there's a theory, talking with anthropologists and stuff, that they discover like old tools that look to be made from like what would have been iron meteorites that would have landed on Earth. So being able to build tools from those, that material that would not have been able to be developed on Earth just yet in terms of like human knowledge and human ability. So things have always hit us. It's hard to find evidence of things that have hit Earth because we're geologically active. So we have the crust and the continents moving in the ocean and ice ages and all this stuff happening that erases evidence of impacts. Whereas the moon, for example, is not geologically active on the same scale. And so you have a lot of crater evidence of impacts.
Okay. Another question from Harry. Why isn't speed of an asteroid factored in to determine the degree of risk? Could there be a rogue or mysterious one to come in from an unpredictable, strange angle or orbit?
Yes, so speed is one of those other things that I put that is kind of also in there. So how fast the asteroid is moving is also, or the velocity of it is also included in that risk calculation. So that would be one that we'd want to look out for, and is incorporated into its calculation as well as the risk. It has to do with like the energy part of it, as far as I remember correctly. But in terms of like, could there be an unpredictable one or a rogue one? We have seen like rogue things enter our solar system, that very long is it Oumuamua that passed through, the cigar-shaped one that came through our solar system, that came from interstellar space. We didn't know it was coming till it was kind of already on its way in here. So there are the possibilities of something coming and taking us completely by surprise, especially when I mentioned kind of at the top, if it comes from behind the sun and the brightness of the sun would block that out and prevent us from being able to see it.
Okay, there's another question in the chat about Hawking radiation. We're just going to put a pin in that for now and just focus on Asteroid Day.
I'm not mentally prepared to answer about Hawking radiation.
Well, we'll answer that in a second, but let's get to our Kahoot. If you'd like to join, the number is there, 297-5897. You go to the kahoot.it to join in, or if not, you can just put your answers into the chat and I'll figure out a way to get it to you, but we'll just go ahead and start playing here and see how this goes. It's not wanting to start. Why is it wanting to start?
No one's in.
Oh, so I can't start it if no one's playing.
No, I'll join.
Okay. That's why I was like, really, why can't I start the game?
Well,
but I got some fun ones. We'll sort of like play Stump Marley here, but we'll see if anyone out there can stump Marley onto the kahoot.it.
It'll probably be easy. Okay, 297-5897. Enter.
As you can tell, we have a daring ant. That is very you, Marley. All right, here we go with our Asteroid Day Quiz. You can all play along at home. You can put the answers into the chat if you like, or you can join here. The number should be at the bottom there still. What Queen song, speaking of Brian May, did he write? Did he write Another One Bites the Dust, Bicycle Race, We Will Rock You, or Bohemian Rhapsody? All great songs, but which one did Brian May write? Oh, We Will Rock You.
He wrote another one that's about time dilation. So I thought that was going to be on here.
The hint was rock you, so we will space rock you. Maybe he was already thinking about that when he wrote the song. Oh, we got a Proud Pony in here as well. 297-5897 for anyone else that wants to play. Here we go. Let's go to the next question. So the DART mission, which is leaving later this year, or is arriving later this year, it's going to redirect an asteroid. It has a CubeSat that's going to be associated with it called Lycia, made by what other space agency? And it is the Italian Space Agency, which I thought was pretty cool because you don't hear about the Italian Space Agency very much, but that was very neat. Daring Ant, you got that one. You got that. Did you know that one, Marley?
Yes, I did. I sure did. Shout out to my Italian family.
So here's a fun fact that I learned recently about Lycia. So Lycia has 2 cameras on them. Do you know what the names of those 2 cameras are, Marley?
Oh, no.
Luke and Leia.
I love it. I love it.
And they both have their acronyms that they kind of like made to fit, of course. I thought that was pretty neat. How much does the meteorite in our gallery weigh? So this picture here, you can see our colleague Raphael and his family. We do have a piece. Is it 5 kilograms, 7 kilograms, 10 kilograms, or 13 kilograms? There you go. Nice one, Marley. I couldn't stump you. 13 kilograms, which is quite heavy. When you look at it, it looks a lot lighter, but because it's mostly iron, right? That's basically where all the weight comes from.
It is surprisingly heavy for the size it is. Yeah.
So if you've never come to our gallery space, definitely come on in and see if you can lift our meteorite. Next question. We talked about Siberia, Tunguska, this event that Asteroid Day is based off of. But what is Siberia? Is it a Russian province? Is it an independent country, a Chinese province, or is it a geographic region? What is Siberia?
I genuinely don't know. I should know this, shouldn't I? I think, yeah.
I don't know. There you go. You got it right. It is a geographic region. I had to look this up too because I was like, I wasn't exactly sure. But so there is no political affiliation. There's no borders or anything. So it's just a mostly desolate region, right? I mean, that was kind of lucky that this event that happened, nobody was living there. It was just basically just forest when this event happened, right?
Yeah. People only stumbled upon it, I think, because they were trying to log something, but I can't remember the exact story.
All right, so one more question for you in here, and Proud Pony, since they maybe got the only points, maybe Proud Pony is going to get this rubber asteroid, unless Lively Quail, who just joined, can get in. Here we go. True or false? Approximately 25 million meteors enter Earth's atmosphere every day. Is it true or false? 25 million. Is it true or false? 25 million meteors enter Earth's atmosphere each day. The key word there is enter Earth's atmosphere. That doesn't necessarily mean that they're falling to the ground, but there's a lot of stuff that's hitting our atmosphere, mostly burning up. But when I saw that number, that kind of like blew me away. Like, wow, our Earth is being bombarded a lot every day. It is true. We are being hit by that. Proud Pony, congratulations. I'll maybe get you this rubber asteroid. Thanks to everyone for playing our Asteroid Day little game here. Let's see how many people did. Clive, We Will Rock You, got it right. Most people got it right. Got some questions right. Another question came in from Fernando on the theme of asteroids. Is there any way to actually use asteroids here on Earth? Is there a way to move their mass safely to the surface without creating a little disaster?
Oh, like, okay. So using gravity against the asteroid to like move it out of the way is how I'm interpreting this question. And that is something that they've looked at doing, but no full experiments on it yet. The only experiment that's being done on asteroid redirection is the DART mission, which is a kinetic impactor mission. So this little satellite will basically just smash into the asteroid, or the moonlet of the asteroid, and try to knock it off orbit. And if it works, then that's a possible way we could do asteroid deflection and redirection. But gravity has not been tested to my knowledge.
Okay. Are you ready for the Hawking radiation question to end us off, Marley?
Let's go.
If you come in here live to YouTube and you ask a question, we will do our best to answer it. If a black hole loses enough mass via the Hawking's radiation, so a black hole is radiating away, can it pop back into being a neutron star, or will it remain a black hole until it eventually evaporates entirely? That's a pretty good question.
That is a really good question. My first thought was no, but often my first thought is wrong. But I do not think it would pop back into a neutron star. But I guess that would also depend on what exactly is the singularity of a black hole anyway. If that's where all the neutrons are, then I guess as it radiates away and gets smaller and smaller, loses enough mass, it could pop back in. Or would Hawking radiation eventually end? I don't know. I don't have a good answer to that one, but my instinct says no. I don't think so.
It sounds like more of like a thought experiment, maybe, but but like, what would you? Because we don't actually know what is going on at the middle of the black hole, right? That would really be the key. If everything radiated away, what would be left? What would be left? Yeah, is kind of the big thing. Interesting. Well, that's a great question, Fernando. Marley, maybe think on that for our next Astronomer. But you're on vacation for our next show, Marley. That's correct. On July 14th, we will have a special guest. We've got Natalie Willette, who works with the CSA. She works out at the University of Montreal. Of course, there is big news happening. JWST is releasing its first images. We will actually have a free event, a free party to unveil those first photos. It'll be quite early here on the West Coast, 7:30 a.m. on July the 12th. If you want to come, you'll be part of the feed that will be broadcast worldwide on NASA because they're going to be going to different locations as we show those pictures. So we'll focus mostly on those JWST pictures for our next episode on July the 14th. So come on back and join us at 2 p.m. Pacific time right here on YouTube. And until then, take care, everyone. Happy Asteroid Day. Wear your sunscreen. We'll help you from the asteroids, but it'll help you from the sun.
Help you from the sun.
Take care, everyone.